Oh, so now you're calling him old.
Yes.
All right. We are starting chapter 4, and we will be in this chapter until Christmas break. It is the longest chapter. It is the most important chapter of our textbook, because this one chapter contains almost everything you need to know going into Algebra 1 next year, which is a high school class that you'll be taking as 8th graders. Okay? If you do not pass this test, that is a huge problem going into next year. So you're really gonna, if there's ever a chapter to focus in on, it's this one. It's got a lot of new material and it's got a lot of stuff you're gonna see again next year. Yes?
Is this one of those things that we're going to use like after school's over, or is this one of those things like you just need to know for later in school?
I mean, depending on what you do in your life, it's hard to answer that question without knowing. If you're not going to do anything in math, then there's almost nothing that I could teach you from this chapter that you would use outside of the school then. But there's things, for example, if you're wanting to own your own company and you're wanting to look at profits and you have revenue, you have profits, you have costs. Those are all things that are actually in this chapter that are really important. Okay, so even someone who just wants to start their own business would need to know some of the stuff. Yeah. That's like saying, but I go shopping and I don't use slope-intercept form when I go shopping. And I'd be like, yeah, I know that. You probably wouldn't, but there's something about math that you've used when you've gone shopping before. Maybe it's applying a discount. Something's 20% off. Someone had to teach you how to find that, right? All right, let's get started. Okay. So it's an important chapter, and it's going to start off very basic for you. A linear equation is an equation whose graph is a line. Very basic. It's usually written in the form y equals mx plus b, where m and b are real numbers, which means they exist, like all the numbers that you've ever seen before in your life. Okay. The points on the line, because a line is made up from an infinite series of points, the points on a line are solutions to this y equals mx plus b equation. Each point on the coordinate plane can be written as an ordered pair. So yesterday we played Coordinate Battleship. Yesterday we had an IXL that was assigned that's due tomorrow. Mrs. Myers is going to remind you of that when you come in tomorrow. She obviously in a work paper for that. But yeah, so there's an IXL that we did that again asked you about the coordinate plane. We're going to be all over the coordinate plane in this chapter. You can make a table, I had to think about that one, of solutions to graph an equation. Like we're going to do here for this one. This is the equation y equals negative 2x plus 1. So to graph a line, you need at least 2 points. Because if you 1 point, you could draw a line that goes any direction through that point. But if you got 2 points, you just, boom, you just set the direction right there. Now I'm going to have you do 3, because if you can do 3 points and they all line up, you know you have the right answer. If I had 1 point wrong or right, and I got the other point wrong, my line's wrong. But if I got 1 point right, 1 point wrong, and another point right, I know something's out of whack and I can check my answer before I move on. So we're going to do 3 points. We're going to figure out where this line's at when x is -1, when x is 0, and when x is +1. Now, why did I choose those 3 numbers? Brady? It's nice to know what's happening on the negative side of the x-axis and what's happening on the positive side of the x-axis. That's a good point. Also, I think I picked the 3 easiest numbers to plug in. 0 and 1 and -1 are like the easiest numbers to plug into any equation. So let's plug in -1 first. If I plug in -1, that means I have to do -2 times -1. What's that? 2 plus 1. 2 plus 1, 3. So when I plug in -1 for x, that makes the y coordinate then, because it's y equals that makes the y coordinate 3. And so that's the coordinate point -1, 3. Take a minute to go graph that. Take a second to go graph that. I don't think you need a full minute. Now plug in 0. What's -2 times 0? 0. What's 0 plus 1? So when I plug in 0 for x, it gives me the y coordinate 1. So I know when x is 0, y has to be 1. Now right there, that's enough to graph a line. But if I want to make sure it's right, I choose one more point. So let's plug in +1. -2 times +1. -2. -2 plus 1. -1. So when I plug in 1 for the x coordinate, so I get to choose what I plug in for the x coordinate. And then I plug it in. We call that, we'll have a name for this later. It's called the input. That's what I'm inputting in. And then that outputs the y coordinate. Okay, so I input a negative or to a +1, it outputs a -1 for the y coordinate, and then I go over and graph that on the coordinate plane. 1, -1. And if these line up, that means I did it right. Do they line up? So I'm going to go ahead and graph it. And on Notability, you can create a line by holding down, and it makes a straight line for you. And I'm going to put an arrow on that side, and I'm going to go and connect it, and I'm going to do the same thing on this side. Draw your line so that it goes all the way through your graph, and so that it has arrows on both sides. Otherwise, it's just a segment. You guys know the difference between lines, rays, and segments? You didn't learn that? Line segments end on both sides. So if you don't put arrows, that means it's a line segment. If you only put one arrow, that makes it a ray, because a ray has an end point, start point, and it goes on forever. And then lines actually go on forever in both directions. So we want 2 arrows. For the most accurate results, choose at least 3 values to plug in for x so that you know you're right. Now I have to preface this. If you plug in 3 values and they don't line up, it doesn't necessarily mean that you're wrong. It just means that what you were graphing wasn't a line. If your equation is able to look like this, y equals mx plus b, it's going to be a line. What about this one? Does this one look like y equals mx plus b? Looks like y equals mx squared plus b. Okay, so let's see what happens here. Let's plug in -1. What's -1 squared? +1, because 2 negatives make a positive, right? So that's +1. What's +1 minus 2? -1. So when I input -1, it outputs -1. Take a moment to go graph -1, 1. Sorry, -1, -1. Should be in quadrant 3. Have you done the IXL yet? So you know when I say quadrant 3, which one I'm talking about? Yeah. Bless you. Now, you might be thinking to yourself, is this what the homework looks like? Yes. How do I do this on my work paper? Well, I'm never going to have you draw a graph on your work paper because Big Ideas has the graphs for you already there. What I'm going to do is I'm going to have you show your work. What are you getting when you input the values they give you on Big Ideas? Like they're going to tell you, plug this in for X and plug that in for X. Okay, so show that work. And then you can graph it on Big Ideas. You do not need to draw graphs on your work paper. Okay. What about when you plug in 0? What's 0 squared? 0. And 0 minus 2 is -2. So when I input 0 for X, that makes the Y coordinate be a -2. So that means when X is 0 on this line, Y is going to be -2. Okay, now we're going to plug in 1. What's 1 squared? 1 minus 2, -1. So I input 1, I get a -1 for Y. So graph 1, -1. Do these points make a line? No, they do not. Okay, they are not all lined up together. Actually, it makes what looks to be a V. But it's not quite even a V. Let's go a little farther out on the x-axis and see what this looks like. Let's plug in 2 for x. What's 2 squared? 4. So when x is 2, I get 2 squared is 4. And what's 4 minus 2? 2. So when x is 2, y is 2. What about when x is negative 2? What's negative 2 squared? Still 4, because a negative 2 squared, negative times negative is still positive. And then 4 minus 2 is 2. So when I plug in negative 2, I get positive 2 again.
I have an idea.
Do you know what it is, Owen? A parabola. Nice job. You'll do a lot with parabolas next year in Algebra 1. Just to give you an idea of what a parabola actually does look like, though, let's go one more value. When x is 3, what's 3 squared? 9 minus 2 is 7. So when x is 3, y is 7. And then that means when x is negative 3, y is also going to be 7. And so a parabola looks like a U. And that's why I wanted to add a couple extra points. You can add as many points as you want to see what the graph looks like. I wanted to add some extra ones because with the 3 that we did, it just looked like a V. But actually, when you zoom out and actually plot some other points, it's a U. And so a parabola will always look like that. Now, parabolas can also be inverted. They can be upside down. We'll talk about those next year as well. But for pre-algebra, we just focus on linear equations. So when they give you one like this, it's obviously not linear. It's not one that we're going to focus on this year. And you can tell it's not going to be linear because of the squared. In the original equation, I said all lines that are linear can be written like this. There is no exponent with the x, okay, which is the next blank. The equation's not linear. Linear equations have an x exponent of 1, which means you wouldn't even write it, or 0, which means it's not even there. We'll look at some of those in a second. Yes.
So basically anything added on to the.
You see any exponent with that x other. So for this one, for example, because it's not there, we would assume it's raised to the first power. This will be linear. If you see any other number there, it's not linear. If you see a 2 there, it's most likely a parabola like the one that Owen just pointed out.
So not all exponents are going to make a parabola.
They don't all. Nope. Some will look like this,
That's strange.
like that. Okay. Some will make like a double parabola, like a double U, like that. It just depends. Yeah, Shane. Yes.
Shane, a little too late.
Yeah, thanks for asking them. All right, so with this one, we know it's linear because of the x exponent being a 1. It's implied it's a 1 because it's not there. So I've changed it up and changed it to -2, 0, and 2. The reason I did that is because you get to choose what values to plug in for x. So you want to choose the easiest ones. What would have happened if I would have plugged in a 1 right there? What's -1/2 times 1, Brady? What's -1/2 times 1?
Negative 1.
What's -1/2 of 1?
Wait, yeah, negative 1/2.
Okay, -1/2, thank you. And so I don't think it's as easy to graph a half or a -1/2 as it is to graph integer values. And so if I plug in 2 or -2, like I'm going to do, half of 2 is 1. So pick numbers to plug in that are easy. So when you plug in -2, negative times a negative is a positive, and half of 2 is 1. 1 plus 3 is 4. So when I plug in -2 for x, I get 4 for y. And I'll go over and graph that. Up there in quadrant 2. When you plug in 0, 0 like is always one that you want to plug in though. When you plug in 0, what's -1/2 times 0? No such number. 0 plus 3 is what? 3. So when I plug in 0 for x, I get 3 for y. So I plot 0, 3. And then when you plug in 2, what's negative a half of 2?
-1.
Negative 1 plus 3. Negative 1 plus 3 is 2. And so we'll plot 2, 2. When I plug in x for 2 for x, I get 2 for y. And as you would expect, because we knew it should have been linear for this one, it is linear. And so I graphed a line going all the way through the graph from end to end. If you argue with me that that's too much to do, I'll make your coordinate plane 25 on each side.
Oh
And then
my
you can do
God.
that.
At that point, it's just using all of our time, just drawing a line.
Yeah, so don't tell me that it's too much.
You should make it
What if I do?
You should make it infinite so that we have to write it.
Okay, is this equation, whoa, 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 shush. I think you forgot what Shane said. So is this one linear?
Yes.
Yes, it is. There's no exponent there, so we know it's just a 1. And so it's going to be linear. And so I'm changing the values this time to -3, 0, and +3, because it's easy to take a third of 3. What's 1/3 of 3? Carson? 1. So what's 2/3 of 3? 2. Yeah. So if I plug in -3, I'll get -2 minus 4. And if I plug in +3, I'll get +2 minus 4. So again, I didn't plug in 1, 0, -1, just because I don't like how I could graph 2/3, but that'd be really difficult to graph 2/3 on this really small number line. So let's go back up to plugging -3 in. 2/3 of -3 is -2. What's -2 minus 4? -6. So -3, -6 is one of the points that I want to graph. -3, -6 down here in quadrant 3. Plug in 0. 2/3 of 0 is 0. What's 0 minus 4? -4. So I want to plot 0, -4. That's going to be on the y-axis right here. By the way, that point is not in a quadrant. I don't know if you got a question like that on the IXL or not, but if you have a point that's on one of the axes, it's not in any quadrant. It doesn't share the quadrants, it's just not in one. So to be in a quadrant, one's over here. 1, 2, 3, or 4. You have to be in the space of that quadrant. Just in case you ever ask that. And then when we plug in 3, 2/3 of 3 is 2. 2 minus 4 is -2. So plug in 3 for x, you'll get -2 for y. And so 3, -2 is right there. And those points all line up as we thought they should, because this is linear. And then don't forget to actually graph the line that goes through those points. That does not look right. All right. So the next two equations, y equals 0, x equals -4. I left it blank for x because it doesn't matter what you plug in for x. There isn't an x to be plugged in for, which means whatever you plug in for x, maybe it's 1, maybe it's 4, maybe it's -3, whatever. Whatever you plug in for x, what is y going to be? Always 0. 0, 0, 0. Y equals 0 means y is always equal to 0. So let's say I wanted to plot the point 1, 0. 1, 0 is going to be on the x-axis because I didn't go up or down any because the y coordinate was 0. 4, 0, right there. -3, 0, right there. Doesn't matter because I know This line is going to be what we call horizontal. So if you have an equation, not only is it horizontal, but it's actually the x-axis line. Isn't that true? That on the x-axis, all the y coordinates are 0? So you don't go up or down. Yeah. So anytime you have y equals, and then your x value is gone, that means the exponent was actually a 0. Because if the x exponent is 0, that's all gone then. Okay. So whatever's left tells you what the y coordinate is going to be. So this line, a line that looks like this, where it starts with y, and then it just is equal to a number, there's no x value at all. This is always going to be horizontal. Y equals 8, y equals -2, y equals 7. These are all horizontal lines that all the y coordinates are 7 on. Or y equals 6, they're all 6, whatever. The same is true for the x coordinates. This one's telling me that that no matter what, my x coordinate always has to be a -4, -4, -4. It's always, x is always equal to -4. So no matter what whatever I use for y, the x coordinate is always 4. So let's just do 0, 3, and -4. Plug in whatever you want to for y. X always has to be -4. If x always has to be equal to -4, all the points then are going to be on this line. Because on that particular line, all the x coordinates are -4. So I think the 3 I used were -4, 0, 4, 3, and 4, -4. And it, again, doesn't matter because it's just going to be a horizontal line. Or not, sorry, not horizontal. What do we call this line? Vertical. Yeah, vertical line. And that's new for us. So I've got this kind of summary right there, that if you have a graph of an equation that's just y equals a number, horizontal. If your graph is just x equals a number, it's vertical. If it's got an x and a y, like all these other ones did, not vertical, not horizontal, diagonal. Most lines are diagonal. Okay. It's got x and a y, it's gonna be diagonal. Unless, of course, it's got an exponent, in which case then it's just not linear. So I don't need to make a chart for this one. If I told you the y coordinate was always -3, do you think this would be horizontal or vertical? Horizontal. No matter what, the y coordinate always has to be -3. Here's -3 on the y axis. So if the y coordinate always has to be -3, that could be a point, that could be a point, that could be, it doesn't matter. Just draw a horizontal line that crosses the y axis at -3. Maybe that's your shortcut. Maybe when you see y equals -3, just know that it's going to cross the y axis at -3, and there's your horizontal line. And same could be said for the next one. If x is always equal to 2, and we know it's going to be vertical, go to 2 on the x-axis and draw a vertical line. Maybe it's 2, 0, 2, 3, 2, 5, 2, 4, 2, -4. It's always going to be a vertical line that crosses the x-axis at 2. Okay, this graph looks really nice. I want to meet the person who sketched this graph themselves and spaced out it perfectly.
You don't even put lines in it. What the heck?
Yeah, how are we supposed
I just said I'd like to meet the person who did it.
you
Tell them how awesome it is.
you make it.
All right, it says the wind speed y is Carter talking. The wind speed y in miles per hour of a tropical storm is y equals 2x plus 66, where x is the number of hours after the storm enters the Gulf of Mexico. So x is a time in hours and y is a speed in miles per hour. It wants us to graph the equation. Now I would normally plug in 0, -1, and 1. However, according to this coordinate plane, I can use values of 0, 1, 2, 3, 4, 5, or 6 for x. I can't use any negative values for x because negative values would mean negative time, which means it's before it moves into the Gulf of Mexico, which I'm not tracking that. So I could use 0. And just to space out our points a little bit more, why don't we use 0, 3, and 6? Just to space out across so we can get a equal distribution across the x-axis on this coordinate plane here. When you plug in 0 for x, what's 2 times 0? Plus 66. Okay, so graph 0, 66. When you plug in 3 for x, Garrett, what's 2 times 3? And what's 6 plus 66? 72. So graph 3, 72. Or your best estimate. And then Deegan, plug in 6 for x. What's 2 times 6? And what's 12 plus 66? 78. By the way, this is called a t-table. It's the exact same table that we were using up here, except I took out the middle parts and I took out this part, which is pretty obvious. Like that was just writing it as a coordinate plane point, right? So it's just got the x and the y. So it takes the work middle chunk of it out, which I don't think we really needed to show our work for this one. I mean, Deegan doesn't need a calculator to do 2 times 6. And he probably doesn't need a calculator to add 12 onto 66 to get 78. So graph 6, 78. Now 78 is not on the graph, so use your best judgment. Again, our graph is counting by 2s. So it'd probably be up in this area here. Also, because I know the graph is linear, I know that it should form a line, and ours does. So go ahead and graph the line. It's one thing to plot the points, but you definitely have to graph the line. Big ideas will graph the line for you if you plot the points. But on your quiz, you have to graph the line. You can't just plot the points and say, all right, quiz, take it from there. You have to draw the line. I'm not going to give you guys rulers. I'm not going to be super judgmental if your line's not notability straight, but just make it as straight as you can. A good rule of thumb is the more points you use, the easier it is to keep your line going straight. Right? Like if I knew that there was a point here and a point there, it'd be really easy to make sure my line's staying on a straight narrow path. Okay. All right, so let's answer some questions about this. When does the storm become a hurricane? Now, a tropical storm becomes a hurricane when wind speeds are at least 74 miles per hour, which means the speeds have to be less than or equal to or greater than or equal to. Person? Greater than or equal to 74. That's right. So when in this tropical storm does it become a hurricane then? When does it have speeds that cross or equal or greater than 74, Xander?
At 6 hours.
At 6 hours. At 6 hours, it's 78 though. So it's before 6 hours.
Okay.
According to our line that we drew, which is somewhat accurate, do you see 74 miles per hour on the y-axis? It's between 76 and 72, right? Okay, so according to our chart, our line that we drew, that's going to happen right around how many hours? 4. And honestly, if you would have plugged in 4 as one of your numbers, you would have gotten exactly 74. And so our storm will become a hurricane after 4 hours. After 4 hours of entering the Gulf of Mexico. Okay, has anyone tracked hurricanes before? Do you pay attention to the Weather Channel when they have tropical storms? Okay, you realize that the longer, like it picks up speed as it goes, right? So it's going to pick up speed. It's going to pick up speed as it enters the Gulf of Mexico. And then once it hits landfall, that's when it starts to slow down. But even then, it still has lots of huge wind speeds. Yes. Where'd you vacation at?
I think it might have been Myrtle Beach. It wasn't like a super severe hurricane. I'm pretty sure it was only like 75 or 76, but it was still a hurricane.
And it makes for bad beach conditions, doesn't it?
Yeah, one thing we were nowhere near the beach, like miles away from the beach. Actually, I didn't really affect us that much. I in there, have the wing again.
You went back inside?
No.
Oh, okay. That story did not end the way. That was good. Okay, anyway, sorry. Okay, so this equation. This equation is not like the other ones that we graphed. The other ones that we graphed, if you remember, were all solved for y. Solve for y, solve for y, solve for y. Do you remember last chapter when I made you solve for y? Oh, you don't? Oh, well, maybe you didn't do well in that portion of the test then. So you may not have. So to solve this for y, what would I need to do to both sides of the equation? Jacoby? Yeah, go ahead, Christian. Add 3x to both sides. And do you remember me telling you that when you do that, you want to put the x term first and not second? Because we want it to be written y equals mx plus b. So we're going to write this as y equals 3x, positive 3x, so just 3x. And then because it's a positive 1, we'll just put plus 1. And then in this blank right here, go ahead and write the 3x plus 1. We'll show our work. Now, I'm letting you plug in whatever values you want to. 0 is an obvious one that you're going to want to choose. What do you get when you plug in 0 to x? What's 3 times 0? 0, 0 plus 1? 1. So you'll get 0, 1. So that's an obvious one that we'd want to plug in. You always want to plug in 0. So 0, 1's right there on the y-axis. What's another easy number to plug in? 1. So when you plug in 1, it's a different color here. What's 3 times 1? 3. And 3 plus 1 is 4. So when you plug in 1, your y coordinate will be 4. So 1, 4. And then if you plug in positive 1, it makes sense to plug in negative 1, so you know what's going on the negative side of the x-axis. What's 3 times negative 1? Negative 3 plus 1? Negative 2. So when you plug in negative 1, you get negative 2. So negative 1 for x, negative 2 for y. Puts that right there. It's linear. We knew it was going to be linear because it's able to be written in that form. And so we graph this. Make sure you put arrows on both sides. Now, when I go the other direction, it's easy to go up to the right because of the 3 points we used. When I'm going down, I noticed that, and this we'll talk about this tomorrow. I noticed that I was always going up 3 and over 1, up 3 over 1. Did you see that too? That's called a slope. That's called a rise and a run. And lines always have a constant slope. So knowing that it's always going to be constant, you can invert that. You can actually go down 3 over 1, and you'll still be on that line. So that's how I knew what point it was going to go through. One more, last one. Thanks for the last one.
Yay!
Carter, thanks for volunteering. Carter, what's the first thing I'm going to do to solve for y in this equation? Carter, I want to move the x term over to the other side because I need it to look like this.
So minus, subtract 5x from both sides.
Okay. That's going to give us 2y is equal to, and then Carter, do I write the minus 5x first or the 4 first?
You write negative 5x plus 4.
Good job. Yep, squeeze that x term in front of. And then now we're going to divide by 2, which is why I got on everybody for going like this on their chapter 1 test and saying that that was the answer, because I have to divide each individual term by 2. And so that's going to give us y equals, what's negative 5 divided by 2? Brady?
Negative 2.5.
It is negative 2.5. What is it as a fraction?
Yeah.
What is it as a fraction, as an improper fraction?
Negative 2.5. Oh. Negative 5 over 2.
Okay, I'm not asking you to do anything crazy, right? 5 over 2, right? Divide by 2 means 5 over 2. What about 4 over 2? What's that reduced to? Jimmy? 2. Okay, don't forget to write the x like I did. X should be next to the 5 halves. Now, why do you think I made Brady write that as negative 5 halves and not just negative 2.5? Jimmy? That's one of the big things from this chapter. That value that's in front of the x is the slope. Did you notice that? Go back up, go back up, go back up, 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 back up. That means the slope of this equation should have been rise 2, run 3. Is that what we did? Did we rise 2, run 3 every time? Oh my. Whoa. What about this one? That means the slope would have been what?
Rise 2, 2.
It's negative. So I would
Oh,
go
go
down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2, all the way through my line. Now, it makes sense that we would do this lesson and then introduce slope as a necessary next step. Because that's where we're going with this. Yeah, Xander?
But what if it's a whole number?
Great question. If it's a whole number like 3, you can turn 3 into a fraction by putting it over. So rise 3, run 1. Yep. Like, shh, like this one here. So Xander's question is what if your slope is a whole number? Well, in this question, our slope was 3, right? So you can change that to 3 over 1, and you can rise 3, run 1. Okay, let's finish this one. So the equation is -5/2 x plus 2. -5/2 x plus 2. 0 is an obvious one I want to plug in. What else is easy to times by a fraction with a denominator of 2? Xander? What would make the denominator cancel out?
2.
Yeah, 2, exactly. If I do a positive 2 and if I do a negative 2. So let's do the positive 2. -5/2 times 2, or 2 over 1, just cancels out to give you -5. What's -5 plus 2? -5. -3. Okay, so 2 comma -3. Go ahead and graph 2 comma -3. Shush. To plug in 0, -5/2 times 0 is just 0. What's 0 plus 2? Okay, so plot 0, 2. And for the last one, -2. If I do, by the way, if I just do -2, it's the same thing I'm doing here, except I'm going to get a negative answer. Well, actually, negative times a positive is a negative. Negative times a negative is a positive. So this is going to be 5 when I plug it in. And what's 5 plus 2? 7. So graph -2 and 7. Draw the line that goes through. And then double check you're right. Since we know that the number in front of the x should be the slope, that means we should be able to go down. We should be able to go down 5 and over 2, right? So down 1, 2, 3, 4, 5 over 2. Looks good. That is our slope. Homework on this is due Monday. Tomorrow, your IXL Algebra 1's due. Mrs. Myers is going to remind you, but get that done. Bring earbuds tomorrow. See you guys later. Yes, big idea. 4.1.
We had a hotel that was like a few miles away from the beach. I was just standing